Hi everyone, welcome to my YouTube channel. I am Madam Rosmaya. In this video, we are going to discuss on tutorial 19, topic atomic structure. So before you watch this video, make sure you have done the question given in the description. Link PDF question is given in the description below this video. Okay, question 1. Which state in the hydrogen atom corresponds to a radius of 0.8496 nanometer? Okay, you are given a radius. So we are going to use the centripetal force because hydrogen atom, the electron uh, in the hydrogen atom is orbiting the nucleus of the atom in circular motion. So we use centripetal force. mv squared over r is provided by the electrostatic force. So electrostatic force formula is charge of the electron squared, okay, E times E divided by 4 pi epsilon naught. Epsilon naught is the permittivity of the free space, divided also by the radius of the atom squared. Okay, so we rearrange the equation to get the speed v squared equals to E squared divided by 4 pi epsilon naught m, cross multiply divided by m, and then don't forget we can cancel one of the r, so we get rn. Okay, next we are going to combine the centripetal force below with the Bohr's first postulate. So there are two postulate, Bohr's postulate. So the first postulate mentioned that state that angular momentum is equals to the nh over 2 pi. So h is the Planck constant, n is the orbit of the hydrogen, okay, level, energy level, and the angular momentum is given by the formula mvr. Okay, so mvr equals to nh over 2 pi. So to combine the first equation above here, so we need to square root both sides. Square root both sides of this equation, and we get m squared v squared and rn squared equals to bracket nh over 2 pi squared. Okay, so now we combine these two formula. We substitute the v squared for the first formula into the second formula. So we get this, and make the rn radius as a subject. So cross multiply, we get rn equals to n squared h squared epsilon naught over pi m z E squared. So Z is the atomic number. So for hydrogen atom, Z is equals to 1. So we can substitute 1 into the equation here. Then the n is the questions asked for the state. So n is the state, n squared. Planck constant is 6.63 times 10 to the power of negative 34 bracket squared. So permittivity of free space is 8.85 times 10 to the power of negative 12 pi. Then mass of the electron is 9.11 times 10 to the power of negative 31. Okay, Z value is 1 for hydrogen atom, and the charge of the electron is 1.6 times 10 to the power of negative 19. Then don't forget the square here. So we cross multiply to get n. The answer n is equals to the 4. So the state is 4. N equals to 4 for the radius 0.8496 nanometer. Okay, now we go to question 2. An electron is in the n orbit of a hydrogen atom. So this time n is given, n equals to 3. Calculate the orbital radius, the speed, angular momentum, and centripetal acceleration. Okay, so we do to find radius first. We do question A. So we use the same formula where we get r equals to n squared h squared epsilon naught over pi m z E squared. We go back to the first question. So this is the radius that we get just now by combining these two physics concept. We use first Bohr postulate and the centripetal force. Okay, so we get this formula for radius of the hydrogen atom. So we substitute Z equals to 1 because this is hydrogen atom. So we get radius is 4.78 times 10 to the power of negative 10 meter. Okay, next the speed. So for the speed, we use centripetal force. Is provided by the electrostatic force. So we go back to the first question just now. So the first concept we use is centripetal force is provided by the centripetal by the electrostatic force. So we cross multiply to get V squared. Okay, so this is the formula. So now we substitute Z equals to 1 for hydrogen atom, electron charge for pi, permittivity of free space, mass of the electron, and the radius calculated in A is 4.78 times 10 to the power of negative 10. So the answer V, because this is V squared, so we square root the answer here, we get 7.27 times 10 to the power of 5 meter per second. So that's the speed of the electron in the hydrogen atom. Next, angular momentum. So for angular momentum, we use the first postulate. We can use two formula here. We can use MVR, or we can use NH over 2 pi. So we get same answer. So we try for if we use MVR formula. So if we use MVR formula, mass of the electron is 9.11 times 10 to the power of negative 31. So the speed calculated in B is 7.27 times 10 to the power of 5. And the radius calculated in A is 4.78 times 10 to the power of negative 10. So we get the answer, angular momentum, 3.17 times 10 to the power of negative 34 kilogram meter squared per second. So if you use the second formula, NH over 2 pi, okay, so we substitute N equals to 3, Planck constant, and then divided by 2 pi, so the answer is the same. So next, centripetal acceleration. So centripetal acceleration, we can use A equals to V squared over R. So we substitute the speed in A and the speed in B, okay, B squared, then divided by the radius in A, calculated in A. So the answer is 1.11 times 10 to the power of 21 meter per second per second. So that's the answer for 2D. Okay, now we go to question 3. Question 3, find the energy in electron volt of a hydrogen atom in a ground state. So for ground state, N is equals to 1, and for hydrogen atom, Z is equals to the 1. So Z is atomic number. Okay, the previous formula we derive, we get V squared equals to Z E squared over 4 pi epsilon naught mr. And for the radius is N squared H squared epsilon naught over pi mZ E squared. Okay, so for energy is the total of kinetic energy plus potential energy. So kinetic energy is half mv squared. So we substitute this v squared into the equation. So we get kinetic energy formula is given by Z E squared over 8 pi epsilon naught R. And for the potential energy, we use electrostatic force. So Z times E times E divided by 4 pi epsilon naught R. Okay, so the total of energy will be kinetic energy plus potential energy. So kinetic energy plus potential energy, we get negative Z E squared divided by 8 pi epsilon naught R. So potential energy here we have negative, negative. So for total energy also, if we calculate here, we get negative. And in terms of N, in terms of N, so we substitute the R n here into the equation, and we get negative z squared e to the power of 4 m over 8 epsilon naught squared h squared times 1 over n squared. Okay, for this value, if we calculate, okay, for the first bracket here, if we calculate, we get we substitute the value here, E, charge of the electron, mass of the electron, 8, epsilon naught is the permittivity of free space squared, and the Planck constant, and we get, if n is 1, we get, the question asks for the energy at the ground state. So that's why we calculate n we substitute n equals to 1 into the equation. So the answer is negative 2.17 times 10 to the power of negative 18 joule. So this is energy in the ground state. But the question asks to answer in electron volt unit. So we need to convert the joule unit here into electron volt. So we divide by 1.6 times 10 to the power of negative 19. So the answer in electron volt is negative 13.6 electron volt. Okay, so that's the answer for question 3. Okay, now we go to question 4. Okay, question 4. A hydrogen atom is in the ground state. Find the longest wavelength that it will absorb. Okay, ground state, that means n equals to 1. And then the longest wavelength that it will absorb, we can use formula. HF equals to the change in energy, okay, from at initial, energy at initial minus energy at final, okay, because we the change in energy is final minus initial. Then when we put the negative, we get EI minus EF. So this is the formula, and HF, F is C over lambda, HC over lambda equals to E initial minus E final. Okay, so we cross multiply to get wavelength. Okay, for the longest wavelength, so that's mean E2 minus E1. For the longest wavelength, that's mean the change in energy must be the lowest. So the lowest change in energy will be E2 minus E1. So this set of energy, E1 to E1, E2, and so on, is given by the formula negative 13.6 over n squared in the electron volt unit. So we calculate for the ground state equals to 13.6 electron volt in the previous question. So this is n equals to 1 at the ground state. So calculated already in electron volt, we get negative 13.6 electron volt. So we go back to the equation 3 just now. Okay, here we calculated negative 13.6 electron volt in the ground state. So we do the same formula. If n equals to 2, we get negative 3.40 electron volt. So we divide it by 2 squared here. Okay, so this is the formula for energy we use. Negative 13.6 over n squared. Okay, so we substitute into the equation here. So negative 3.4, E2 is negative 3.4 minus E1 is negative 13.6. And then to lambda unit is in meter, so it is in SI unit. We need to convert the electron volt, energy in electron volt, into joule, SI unit. So we multiply by 1.6 times 10 to the power of negative 19. So this is energy in electron volt to convert to joule unit. Okay, so we substitute C also and the Planck constant. C is the speed of light. So we get the wavelength 1.22 times 10 to the power of negative 7 meter. We have another method to solve for question 4. We can use the Rydberg constant. Okay, from this equation, HF equals to EI minus EF. So F is C over lambda. So we can get Rydberg constant from this, where we cross multiply HC to the right side. and EI minus EF. So the formula for E, we use the negative 13.6 divided by n squared. Okay, so because there is a negative in the formula, so the equations become 1 over nf squared minus 1 over ni squared. So this is f, final, and the initial, final minus initial, so n final minus n initial. Okay, so hc over lambda, hc over negative 13.6, hc over 13.6, so we get the Rydberg constant, which is 1.0974 times 10 to the power of 7 per meter. Okay, so we can use this Rydberg constant, where you can get it from the calculator. It is labeled as R infinity. Okay, so this is the value. Okay, you use constant shift, okay, constant, and for Casio calculator, the constant label as number 16. Okay, so the value of Rydberg constant is 1.0974 times 10 to the 7 per meter. Okay, so n for the longest wavelength should be state 2 minus state 1. So 1 over 1 squared minus 1 over 2 squared. So the answer we get about the same. Wavelength is 1.21 times 10 to the power of negative 7 meter. Okay, question 5. Compute the wavelength of the fifth line in the Lyman series. So what is Lyman series? So this is the spectrum for Lyman series. The result is the wavelength between 194 nanometer to 122 nanometer. So the wavelengths of the emitted photons due to the transition of excited atoms to the ground state result in the Lyman series. So also given here is the energy level for the Lyman series. So we have a spectrum given here, 5 altogether. The question asks for the fifth line. So that's mean the result, the first one is N2 to N1, and then N3 to N1. So the third and the fourth. So the fifth will be N6, N6 to N1. So not written here, N6 to N1. So the energy level here is calculated using the formula negative 13.6 over n squared. Okay, so from the formula, HF equals to EI minus EF, E initial minus E final, and F equals to C over lambda. So we can calculate the lambda wavelength of the fifth line in the Lyman series. So this fifth line. So that's mean the E will be E6 minus E1. E6 minus E1. So the formula we calculate using negative 13.6 over n squared. So we will get negative 0.378. So in 3 significant figures. So given in the diagram here is 2 significant figures. So we use 3 significant figures. Negative 0.378 minus negative 13.6. This is E1. And then we are going to convert it to joule because lambda unit is in meter. So electron volt is converted to joule by multiplied to 1.6 times 10 to the power of negative 19. So convert the electron volt to joule unit. And the answer is 9.40 times 10 to the power of negative 8 meter. So that's the answer, the wavelength of the fifth line in the Lyman series. And we can use prefix nanometer. In nanometer is 94 nanometer. Okay, question 6. A radiation of wavelength 80 nanometer ionize a hydrogen atom in the ground state. Calculate the velocity of electron removed from the ground state. Mass of electron given as 9.11 times 10 to the power of negative 31 kilogram. So the formula we use is the principle of the conservation of energy. From the principle of conservation of energy, so HF is energy of a photon, okay, minus ionization energy equals to the half mv squared. Okay, so F equals to C over lambda, so we substitute into the equation above. And ionization energy is equals to the E at infinity minus E1. So E1 is at the ground state, equals to half mv squared. So Planck constant times the speed of light divided by lambda, wavelength given 80 nanometer, convert to meter. Okay, E infinity is 0 because this means the electron can be excited and completely leave the atom. So E infinity is 0. Then minus the energy at the ground state, negative 13.6. And this is in electron volt, so convert to joule multiplied by 1.6 times 10 to the power of negative 19. Okay, equals to half m is the mass of electron times the v squared. So we solve v, we get 8.25 times 10 to the power 5 meter per second. So that's the answer. Okay, question 7. Determine the wavelength of the photon that would ionize a hydrogen atom in the n equals to 2 state and give the ejected electron a kinetic energy of 8.2 electron volt. So we use the same formula from the principle of conservation of energy. So HF equals to bracket E infinity minus E2 plus half mv squared. Okay, so F is C over lambda. So the E, we're going to find using negative 13.6 over n squared in electron volt. So for N1 is negative 13.6 electron volt. So for N2 will be negative 13.6 divided by 2 squared. And the answer is negative 3.40 electron volts. So we are going to use these two energies and substitute into the equation here. Okay, so now H is the Planck constant, C is the speed of light, wavelength is the questions once, the wavelength equals to E infinity 0 minus E2 is negative 3.40 electron volt, and then plus the kinetic energy. So the kinetic energy is 8.2 electron volt. So no need to use half mv squared because it's given already here, kinetic energy 8.2 electron volt. And all this energy is electron volt and convert to joule because we are going to find wavelength. So convert to joule, we multiply the energy is multiplied by the 1.6 times 10 to the power of negative 19. So cross multiply, we get the wavelength equals to 1.07 times 10 to the power of negative 7 meter. So that's the answer. And we convert to nanometer, becomes 10 to the power of 7 nanometer. 10.7 nanometer. Okay, now question 8. Find the maximum wavelength of radiation which will ionize a hydrogen atom in the ground state. So if ionization happen, so that's mean level n is at infinity. So the ionization energy is E infinity minus E1. So E at infinity is 0. So E at the ground state, which is E1, equals to negative 13.6 electron volt. So ionization energy is 13.6 electron volts. So we are going to use this ionization energy and use the HF to find the wavelength. Okay, so ionization energy is the minimum energy required to move an electron from the ground state of an atom to infinity. So if the energy supply is more than the ionization energy, then the supplies energy becomes the kinetic energy of the free electrons. So that's why from the principle of conservation of energy just now, in question 6 and 7, we have half mv squared, the kinetic energy. So this one is from the principle of conservation of energy. So HF equals to E infinity minus E1, so plus 0. The kinetic energy becomes 0. Surplus energy considered, there is no surplus energy, so plus 0. This is for the complete ionization of the hydrogen atom. Okay, next we substitute F equals C over lambda. Okay, Planck constant, C is speed of light, E infinity is 0 minus negative 13.6, and convert to joule becomes multiplied by 1.6 times 10 to the power of negative 19. So the answer wavelength is 9.14 times 10 to the power of negative 8 meter. Okay? So this is the wavelength, the maximum wavelength of the radiation, which will ionize a hydrogen atom in the ground state. Okay, so for the principle of conservation of energy, so the surplus energy plus half mv squared, the kinetic energy is equals to 0. Okay, so that's all for the question for the tutorial, and see you in the next tutorial.